Now, in order to graph cosecant here, this is the graph of cosecant. Now, in order to graph cosecant, what you want to realize is cosecant is really just the reciprocal of y equals sine theta, or sine x. So when I say reciprocal, doesn't that mean I'm kind of flipping it, all the values? Taking each value and doing the flip is called a reciprocal. So what you might notice here is this is the reciprocal of sine. So what I want to do here, on your graph, I want you to graph sine. So watch. Wouldn't sine start here, hit here, drop there, and there? Make sure you do dotted lines. What you should notice here is to graph cosecant, what you're really doing is graphing sine and flipping it. So again, to graph cosecant, you first graph sine as a dotted line, and then every time you hit the x-axis, it's going to be an asymptote. The reason is, what is the reciprocal of 0? Undefined. So every time you have a reciprocal of 0, it's undefined. So you have an asymptote at each of these. So technically, let me write that in. There was really an asymptote right here. It's not marked. So you have the asymptote right there. So every time it hits the x-intercept. So let's write that as a note. X-intercepts are asymptotes. Now, so x-intercepts are asymptote, or another way of saying x-intercept is when sine theta equals 0. When sine theta equals 0 are your x-intercepts. Okay, so next, just real quick, one of the questions might ask, what is the equation of those asymptotes? So let's just, for now, let's talk about it. Can you tell me the equation of each of these asymptotes, just for another thing to jot down? Well, my asymptotes are x equals 0, pi, and 2 pi. 0, pi, and 2 pi are the spots where sine is 0, or the spots where sine has x-intercepts. So in order to graph this right here, we are going to graph it basically as, first, y equals sine 1/3 x. But then we're going to flip it. All right, so if I graph this, can you figure out your amplitude and your period? Well, hopefully you can see your amplitude is 1. Usually there's a 1 right there. Okay. Your period is going to be 2 pi divided by 1/3. And 2 pi divided by 1/3 is 6 pi. So we're going to graph a sine graph with a period of 6 pi and an amplitude of 1. So sine's going to start here. I'm going to make my 6 pi is my end, but every 4, so that right there is going to have a dot, and right here is going to have that 6 pi. What I did again is I made it, instead of this being the end of the period, I made it have 8 spots to be the end of the period. So sine starts here, ends here, in the middle, it hits again. So that right there, I'm trying to make it nice and even, is a full period of sine. Now, isn't that where my asymptotes are going to be?
Yes.
That is where my asymptotes are going to be. So what I have now is I have an asymptote right here, an asymptote right here, and an asymptote right there. Next, what's going to happen between these for sine? Are we going to go up or down 1? Well, my a is 1, correct? So what I'm going to do, I'm going to call this 1 and call this negative 1, is I'm going to go up 1 here and down 1 here. And if I drew sine in, wouldn't this what sine would look like? Wouldn't sine go up and then back down? But we're graphing cosecant. So what would be the reciprocal of this shape? Won't it be up there like that? And what the reciprocal of this shape be like that? So this one's going to go like that, up against the asymptotes. And this one's going to be next to the asymptote, hit and turn. Oops, that was a bad turn. That was a pretty bad turn. But there we go. So we're going to take the reciprocal of sine. Now, make sure you make sine dotted. because it's really not part of the graph. It's just a help to graph it. So I want to graph this one. Can I replace that with a sign to start with in my mind? So my amplitude is 2, but there's a flip going on, so it's going to be upside down. Just be aware of the flip. Just reminds me it's going to be flipped upside down because of the negative. And my period is going to be 2 pi divided by what? Is that a 1 right there? So isn't 2 pi divided by 1 just 2 pi?
Yep.
So I'm going to go, okay, if it starts at sine, when it start here, then it's going to be there, hit again, and then it's going to hit right there at 2 pi.
Okay.
So again, I'm going every 4 is a kind of a marking points. Because I know sine starts and ends at the period. In the middle is another dot for sine. So my amplitude is 2, but it's negative. So I'm going to call this 2 and this negative 2. And halfway between these, am I going to go up or down 2?
Down.
Because it's a negative 2, I'm going to go down. So I'm going to have a dot here, and then I'm going to have another dot here. Okay, and if I kind of sketch that in. Where do I put my asymptotes?
On the dots.
On the x-intercepts. So I'm going to have dot asymptotes right there. And how am I going to graph through that point? Well, I'm going to take this curve and flip-flop it. This curve and do the reciprocal of it. So this one right here will go hit like that. And the other one will go like that. And we just graphed one cycle of cosecant with those specific amplitudes and periods.